Hello guys, welcome to today's lesson. Today we are going to consider another topic, that is carbon. So at the end of today's lesson, you should be able to describe carbon. That is the nature of carbon. You should be able to mention the group and period of carbon in the periodic table. You should be able to name the occurrence as the sources of carbon, carbon as a free element, carbon in combined form. You should be able to mention the isotopes of carbon, name the allotropes of carbon, and also mention the uses of these allotropes of carbon. Thank you for being there. Nature of carbon. Nature of carbon. Is carbon a metal, a non-metal, or metalloid? Now, carbon is a non-metallic solid element. Carbon is a non-metallic solid element with a grayish to black color. Carbon is a non-metallic solid element with a grayish to black color. Now, group and period of carbon on the periodic table. Carbon belongs to group 4 and period 2 in the periodic table. Now, occurrence of carbon. Where can we find carbon? We can find carbon as a free element and in combined forms. You can find carbon as a free element and in combined form. As a free element, you can find carbon in diamond, in graphite, in fullerene, in charcoal, and in combined forms, you can find carbon in organic compounds such as carbohydrate, fat and oils, lipid, and hydrocarbons. Now, isotopes of carbon. Carbon exists in three isotopic forms. Carbon has three isotopes: carbon 12, carbon 13, and carbon 14. The most stable among these isotopes is carbon 12. Carbon 12 is the most stable isotope. Carbon 14 is highly radioactive. It is quite unstable. Now, oxidation number of carbon in its compounds. Carbon exhibits two oxidation numbers in its compound. Oxidation number of +2 and +4. +2 in compounds like carbon monoxide as carbon 2 oxide, and +4 in compounds like carbon 4 oxide and trioxocarbonate 4 salt. Electronic structure of carbon. Carbon has 6 electrons, 2 electrons in the first shell and 4 electrons in the valence shell. Now, allotropes of carbon. Carbon exists in two allotropic forms. Carbon exists in two allotropic forms, the crystalline allotropes and the amorphous or non-crystalline allotropes. The crystalline allotropes include diamond, graphite, and fullerene. Diamond, graphite, and fullerene. While the non-crystalline allotropes or the amorphous allotropes include coal, coke, charcoal, lamp-black, or soot. Now let's look at diamond. Diamond is an allotrope of carbon that has a giant covalent structure. Giant covalent structure. Carbon crystal lattice is made up of atoms of carbon that are connected via covalent bonding. So in diamond crystal, we have a network of carbon covalent bonding. Now each of the 4 electrons of atom in graphite are used in bonding. So because of this strong bonding, diamond is known to be the hardest substance. Diamond is known to be the hardest substance. So in diamond we have a network of covalent bonding. In diamond, we have a network of covalent bonding. Each carbon contributes 4 electrons that are used in the bonding. And because of this network of covalent bonding, diamond appears to be the hardest substance. Now let's see uses of diamond. Because of the hardness of diamond, diamond is often used to make cutting and boring tools. Diamond is often used to make cutting and boring tools. Because of the hardness of carbon, because of the hardness of diamond, it is often used to make cutting and boring tools. Now let's see graphite. Graphite is a form of carbon that is made up of atoms of carbon that are connected in layers. So in graphite, we have carbon atoms that exist in layers, and each layer is connected to the other through van der Waals forces. The layers are connected to each other through van der Waals forces. Through van der Waals forces. The layers are connected to each other through van der Waals forces. Now, uses of graphite. Graphite can be used as a dry lubricant because of its layer structure. The weak van der Waals forces makes it possible for the layers to slide over each other. So because of this, carbon is often used as a dry lubricant. Carbon is also used in making pencil. Now, because of the fact that there is a free electron for each carbon in graphite crystal lattice, and this makes graphite a good conductor of electricity. Graphite is often used as electrode in dry cell and in electrolytic cells. Now, amorphous forms of carbon, we have charcoal. Charcoal can be made from wood, call it wood charcoal. It can be made from animal materials like bone. We call it bone charcoal. Now, wood charcoal is used as an absorbent in gas mass. It is used to absorb poisonous gases in gas mass. While animal charcoal that is made from animal bones is used to decolorize colored solution. For example, it is used to decolorize root sugar in the process of making sugar. Now, coal is an old form of carbon. Coal can be converted into coke, coal tar, coal gas, and ammoniacal liquor through destructive distillation. So the destructive distillation of coal gives coal tar, coal gas, coke, and ammoniacal liquor. Now we have described the uses of these fractions of coal. As a reminder, the fraction coke is used in the extraction of iron and in the making of steel. Now ammoniacal liquor is used as a source of raw material for fertilizer. Source of raw material for fertilizer. Alright, so in today's lesson, we have described carbon. We have described carbon as a non-metallic solid element with a grayish to black color, and that it belongs to group 4 and period 2 of the periodic table. Then that we can find carbon as a free element and also in combined forms. So as a free element, we have carbon in diamond, in graphite, in fluorine, in charcoal, and in combined form, we have carbon in organic compounds like carbohydrate, fat and oils, lipid, and hydrocarbon, and also in inorganic compounds like carbon dioxide, carbon monoxide, and the carbonates. We also mentioned the isotopes of carbon to include carbon 12, carbon 13, and carbon 14. And we said that carbon 12 is the most stable isotope. Electronic structure of carbon. Carbon has 6 electrons. There are 2 electrons in the first shell and 4 electrons in the second shell. Okay, now the allotropes of carbon. Carbon exists in two allotropic forms. Carbon exists in two allotropic forms, crystalline allotropes and non-crystalline or amorphous allotropes. Crystalline allotropes include diamond, graphite, and fluorine, while the non-crystalline allotropes include the non-crystalline form include coal, coke, charcoal, coal gas, coal tar, and soot. Diamond crystal lattice. Diamond crystal lattice is made up of a network of covalent bonds. Diamond crystal lattice is made up of a network of covalent bonds. Graphite is made up of layers of carbon. Graphite is made up of layers of carbon that are connected via van der Waals forces. All right, so uses of these allotropes, because of the fact that diamond is very hard, it is used in making cutting and drilling tools. And for graphite, because of the fact that graphite has free electrons in its crystal lattice, it is used as electrode in dry cells and also in electrolytes. Sorry, and also in electrolytic cells. The amorphous form of carbon we have wood charcoal is used as an absorbent in gas mask, while animal charcoal made from animal bone is used as a polarizing agent.